All right, these are the answers to worksheet 3.4. For the first one, we're doing critical numbers. So we're going to take the derivative here. Y prime will be 20x cubed minus 20x. And then we're going to set that equal to 0. There's nowhere that's undefined, so we don't have to worry about that. I get 20x times x squared minus 1, which is 20x times x plus 1x minus 1. And so that means when x is 0, negative 1, and 1, those are our critical numbers. Okay. Now, as far as when are we increasing, decreasing, what we need to do is test those intervals and see when the derivative is positive or negative. So I'm going to test y prime here. And if I put in, say, negative 10, I'm going to get a large negative. That'll make this negative. So that means my function is decreasing there. Between negative 1 and 0, if I put, say, negative 1/2 in, I'm going to end up with a positive value there. So my function is increasing. If I put in, say, positive 1/2 now, I'm going to get a negative value this time, decreasing. If I put in a large positive, I'll get positive value, so I'm increasing. So we're increasing from negative 1 to 0, and from 1 to infinity. We're decreasing from negative infinity to negative 1, and from 0 to 1. All right, where's my relative max? That's when my derivative switches from positive to negative, and that happened at x equals 0. And relative minimums when the derivative switches from negative to positive. That happened twice at negative 1 and positive 1. All right. As far as my second derivative test goes, now I'm going to take the second derivative, which is 60x squared minus 20. Set that equal to 0. So I'll pull a 20 out of there, which is 3x squared minus 1. And if I set this equal to 0, add 1, divide by 3, I get x equal to the positive or negative square root of 1/3. All right, which is kind of an odd number. And if I do my test on that, negative square root of 1/3, positive square root of 1/3. If I try 0 in there into this derivative, I'm going to get a negative. So that means we're concave down. And I need to test something positive. So it could be something big like 10. I'm going to get a positive there. I'm going to get a positive here. So we're concave up. So even though it's a weird number, it's easy to pick some numbers that are in those intervals. So we're concave up from negative infinity to negative square root of 1/3, and from square root of 1/3 to positive infinity. And we're concave down in between. And our point of inflection, well, we did have switches and concavity at both of those spots, so both positive and negative square root of 1/3 are points of inflection. It says plug in your critical numbers in the second derivative. Does this confirm? What this means is that if you were to put, say, negative 1 into the second derivative, we'll get 60 times negative 1 squared minus 20. That's 40, which is a positive. That means at that critical point, the function is concave up, which means that that should be a relative minimum. And that's exactly what we had it for. And you could do that for each of the other ones, and you should have the concavity match whether it's a maximum or a minimum based on that answer. So could we make a little sketch of this? Well, what we're saying is that negative 1 and 1 are relative minimums. 0 is a relative maximum. So at negative 1, at 1, 0, this function is kind of coming in like this. So we have our minimums, maximum at 0, concave up until about square root of negative 1/3. I'm sorry, negative square root of 1/3. Again, concave down until square root of 1/3, concave up after that. Something like that. We could find some actual function values to secure it into the graph, but this is a good sketch of what that looks like. For number 4 here, we're again looking for critical numbers. So I take the derivative, which is 9x squared minus 9, and set that equal to 0. If we pull the 9 out, it'll be x squared minus 1, which we're familiar with, same as last time, x plus 1, x minus 1. So we get x equal to negative 1 or 1. So those are critical numbers, negative 1 and 1. As far as the first derivative tests, let's go ahead and put that down, negative 1, 1. If I were to try something less than negative 1, say negative 10 in here, I'm going to get like 900 minus 9. That's a positive. So our function is increasing here. If I were to put 0 in, 0 minus 9, I get a negative. Function is decreasing. If I put something bigger than 1 in here, I'm going to get a positive. My function is increasing. All right. So we are increasing from negative infinity to negative 1 and from 1 to infinity. And we're decreasing from negative 1 to 1. Okay. Whereas my relative max, that's when we switch from increasing to decreasing. So that's at x equal negative 1. Relative minimum is when we switch from negative to positive. That's positive 1. Then we are asked to find the absolute max and absolute minimum on an interval negative 1 to 2. So what we're going to do is we're going to set up real quick a table for that. Negative 1 to 2. Our critical numbers in between there are positive 1. We don't need to try 0. We don't need to try anything else. So we're going to put those into the function. So negative 1 cubed is negative 1 times 3 is negative 3. Negative 9 times negative 1 is positive 9. Negative 3 plus 9 would give us 6 for that. If I put 1 in there, I'm going to get 3 minus 9. That's a negative 6. If I put 2 in there, I get 3 times 8, 24 minus 18, and that's positive 6. So our absolute maximum is positive 6. That's the highest value in the table. And the absolute minimum is negative 6. Now, as far as the second derivative test goes, we're going to take the second derivative here, which is 18x, set it equal to 0, and that gives us a possible flex point of x equals 0. Won't know if it is until we test it. If we pick something negative, put it in, we're obviously going to get a negative value in the second derivative. If we pick something positive, we'll get a positive value. Okay, that means we're concave up, or concave down here, concave up here. So we are concave up from 0 to infinity. We are concave down from negative infinity to 0. What's our inflection point? Well, since we had the change in concavity, it would be at x equals 0. So use our second derivative to confirm our relative max or minimum. So again, if I were to take the second derivative of negative 1, it would be 18 times negative 1, which is negative 18. That means the graph is concave down at that critical point. So that means it should be a relative maximum. If we look, we have a relative maximum at negative 1. So confirms we could do something similar at 1. 18 times 1 would be 18. That means we're concave up. So that critical point should be a relative minimum. And sure enough, that's what we have. So we have confirmation there. Now we're supposed to sketch the graph of this. So we have a graph that is increasing from negative infinity to negative 1, decreasing from negative 1 to 1, and then increasing again. So something like this, coming up, turning again, and then going up like that. So something like that would look like that.